This video mainly focuses on the primary auxiliary view. Normally, we'll have a primary and a secondary auxiliary view at the type of the given surface. If the surface is an inclined surface, then we can use the primary auxiliary view, and then if the surface is an oblique surface, we can use the secondary auxiliary view. If you want to know more about what's an inclined surfaces, you might refer the video related to the projections of the surface. You can get this accesses on the video description. The purpose of the auxiliary view is just to get the exact side and the exact shape of the given object. It's known that if the object is an inclined surface or an oblique surface, it might not have any true shape on either of the 6 principal views. This is why we use just a supplementary view or auxiliary view to get the exact size and the exact shape of such types of a given object. Based on the projected surface, we can divide the auxiliary view into partial auxiliary view and a complete auxiliary view. In the case of partial auxiliary view, we can project only the slanted surface, and then in the complete auxiliary view, we can project all the surface which is just from the view of the slanted surface. In most cases, we use a partial auxiliary view instead of a complete auxiliary view. Let's start constructing the primary auxiliary view of this object. The front view of this object is from this direction, and then the left side views of the given object is from this one, and then it is constructed with the first angle projection system. So once we construct all the multi-view drawings of this part, we can get this surface. The corner point to construct this inclined surface can be labeled in this way. These pointers will help us to transfer the dimensions of this surface into the exact surface. The views of this inclined surface from the front view can be sketched in this way, and it's a distorted surface. The exact shape of the surface is not projected here. And in the other one, if you look at this one from the left side view, you can get an edge here. So this is just a line from here to here, and then all the pointers at the lower part, that means points A, H, E, and D will be just aligned at the same point, and the middle one, G, F will be aligned over this one, and then B and C will be aligned over this one. So the views of this inclined surface from the left side view will be just like this line. And then finally, once we get all these necessary pointers, we can project a perpendicular line from this slanted line in this way. By considering the space we have to construct for a primary auxiliary view, we can draw the auxiliary plane line at a wished distance. The auxiliary plane line should be parallel to this edge view. We can measure the distance from the principal plane line to each point, and then we'll transfer that dimension with the reference of the auxiliary plane line. Now let's start from the lower part. We have 4 pointers, that is point A, H, E, and D on the lower parts of this point. We can measure the distance from this reference plane line into these 4 pointers, and we can transfer this dimension into this one from the references of the auxiliary plane line. And then if you do that, since we have 4 pointers over here, from here to here it will be point D, from here to here it will be point E, from here to here it will be point H, and then from here to here it will be point A. And then all the pointers can be scattered in this way. We can measure the distance from this reference into the other pointers, that is point B and point C. If you measure that, you can get this distance, and then on this line you can measure all those pointers, and then you can transfer that dimension, and then finally point B and point C can be located over this specific location. The remaining pointers are point F and point G. So you can refer this line, and then you can measure from here to here, and then you will get that dimension. And then you can transfer all those pointers, and then finally you will get the exact positions of point G and point F like this one. The last thing is we can connect all those pointers starting from the initial corner point in this way. That means from point A, B, C, D, E, F, G, and H, just like this one. And then the last one is from H into A. Finally, we can get this auxiliary view. So this auxiliary view is just with a true size and a true shape. So we can find out that inclined surface with a true size and a true shape. It will help us to give the dimensioning or to know the exact size of the given surface, just like this one. Now let's add one feature here. The feature is just the bore of this surface. So if we bore this one with a circular feature like this one, finally we'll have this object. So this object will have a curves in the auxiliary view. To construct such curves on the auxiliary view, we can use the division method here. So we'll divide this circle on one view and then we'll try to transfer it into the auxiliary view. If you look here, this is just the circular feature on the front view, and then this one will be on the left side view. So the circular feature is on this portion on the left side view from here to here, which is represented with the hidden line. Now let's divide this circle into the number of sectors. If the number of sectors increase, then the accuracy of the represented view will be increased. And then if you divided this into less, then the representations of the surface on the auxiliary part will not be as exact as expected. So let's divide this one into 12 parts. So if we want to divide it into 12, that means 360 by 12 will be a 30 degree. So each sector will have a 30 degree measurement, and then their divisions will be in this way. So we just divided this parts into equal sectors. Now we can draw a construction line from each point to the inclined surfaces of the view like this one. So from here to here, we'll just transfer all points. In this case, points 3 and 5, 2 and 6, 1 and 7, 12 and 8, 9 and 11 are just on the same line. And then once we do this, we can draw a construction lines which are perpendicular to this edge and then extended from these lines, just like this one. Then the same procedure can be applied. From the reference one, we can measure the distance between this vertical reference line up to the points of the division. So from here to here, if you measure this one, you will get 0.1, and then from here to here, you will get the measurements of 0.2. From here to here, you will get the measurements of 0.3, and then from here to here, it will be the measurements of 0.4, etc. Once we measure all the dimensions of the pointers from the principal plane line, that means the first reference, and then transfer the dimension into the auxiliary plane by the auxiliary plane line, then finally we can get all the 12 pointers scattered in this way. And then once you get all those pointers, you can use a French curve to connect them, and then by using a French curve, you can just connect them, and then finally you'll have such types of elliptical curve. Let's see a practical example here. For example, if there is a house just like this one, and then if you look this house from the front view, you will have this surface, and then from the right side view, it will have this surface. If you look the views of the roof, it is just distorted on the right side view. So how we could get the exact sizes of this roof? If we just use the roof as of the views here, it will have such types of cover, or the roof will be this one. So we have to use the auxiliary view to know the exact size and shape of the roof. If we use that technique, so finally you'll have this surface. So this is just the auxiliary views of the view. That means we are just looking from this part. So once we have this surface, so the roof will be just with exact shape, and then it will fit on the house. This is the video related to the primary auxiliary view. You can just get the other types of views in this channel. If you enjoyed the video, you might like and share, and then don't forget to subscribe our channel. See you soon.